Now comes the code. So what I'm first actually going to start off with is our old .h, which is now our .java. And again, remember that everything's combined into one document here. There's not a lot of change here. First, we have our public class. Normally it's just class. Here again, well, we've seen private in C++ and public class, so that's really nothing different. What is different though is that every data member or function has to have a public or private in front of it. Now, I take it back. Notice the constructors, the constructors are exactly the same. There's really no difference here. Notice they don't have the word public in front of them. If you don't have public or private in front of a function name, by default it will set it to public. So notice the constructors. There's really no difference on that. Notice there's three different ones here. Now, by the way, I'm going to do something real quick. I'm going to comment or take this one out real quick. And it's going to have an issue. Is that in the student driver, notice there's an X there, shows you that's an error. Is that in Java, as soon as you create a non-default constructor driver, then you need to have one and put one in, and then it'll be happy with it. So be very, very careful. That is a Java thing, so be very careful. Your other functions, which you've seen before in some of the other videos, again, the overall setup is quite similar. You don't have the scope variable. You just have if it's public or private. Had that before. Notice, by the way, you can intermix the public and private, so there's not just a section of public and then another section of private. There really isn't. I could make this private and would have no problems with it at all. There are some other bigger nuances, so I'll get into that later than maybe what C++ has, but that's the overall setup when it comes to the .h part, which is just our Java here. Now in driver, creating our instance is a little different only because it looks like a heap variable, but other than that, it's exactly the same. Here's one that's using all of the functions that are already established in student.java. I was almost going to say .h. And there's a couple more examples. Let's see here. Here's a constructor using with a spelled Thomas wrong, but basically using the constructor and adding more fields. Here's a bigger one using the third constructor. So notice that's really all the same. Now the one thing that is massively different than what we're used to, we would use an overloaded cout for, is our print, but that's not the point. Is that this print works in a special manner, meaning that, number one, it says, well, geez, I'm printing out a student. Now, as you know, in overloaded cout, we do it for each object that we want. Now, how does Java know what to do with this? Well, in Java, it should be at the very end here. Nope, no, it's not. Go figure. Where's my toString? There it is. If you want to have just basically like your overloaded cout, you use the toString function to basically do the exact same thing. Here we are getting all of our data members together and then formatting it in some way exactly like we would do in an overloaded cout. There really isn't any difference except for two things. Number one, this does do a return, which I believe the overloaded cout still did. Notice it is going to be a string, so we might actually have to do some changing of values from double to a string, but again, notice that all these functions did that kind of beforehand. And then if it has a toString function, it'll look at the object, know it needs to print out a string, so it'll automatically call the .toString. So this would actually do the same thing, toString. So you notice it even pops up. Okay, that would do exactly the same thing as what the code was before. That's the only real big difference when it comes to overloaded couts in Java and C++, but at least the overall connotation is still there.